Section 7.1 on linear and nonlinear systems. So a system of equations is more than one equation graphed on a plane. A solution to the system is any point the equations have in common. The solution is the intersection of the equations. So today we're going to look at solving systems of equations either by substitution or by graphing. So if we're looking at the graph of a system, if they intersect at one place or two places, those are the solutions to the system. If they don't intersect at all, then there's no solution. When we are solving by substitution method, which we'll look at some examples in a second, there may be a couple of times or situations where you get some weird answers. So as long as you get an x and a y value, that would be the solution to the system. But if you get a weird answer like a number equals another number, then that would be no solution. Or if you get an answer where a number equals itself, like 5 equals 5, then that would be infinitely many solutions, which means that the two equations are exactly the same. So let's look at some examples on solving using substitution. Before we get to those, we're going to look and determine if these two ordered pairs are the solution to this system. So what that means is we're going to plug in the first ordered pair, -2, 0, into both equations. It would have to work in both equations in order for it to be a solution to the system. It can't work in one or the other. It has to be in both. So I'm going to start by plugging in -2, 0 into the first equation. So -2 is going to go in place of the x and 0 in place of the y. So I'm trying to see if 0 is going to equal -2 times e to the -2 power. And I can just type all of that into the calculator. -2 times e to the -2, and that's about -0.27. Well, obviously that's not the same thing as 0, not equal to 0. So this means it's not a solution to the first equation. So if it's not a solution to the first equation, I don't even have to try it in the second equation. It's not a solution to the system. Okay, now we're going to try B, 0, -2. So I'm going to put 0 in the place of x and -2 in the place of y. So first let's plug it into the first equation. So I'm trying to see if -2 equals -2 times e to the 0. So you can type that into your calculator, and it turns out that -2 does equal -2. So that's good. Now I need to plug that ordered pair into the second equation because it has to work in both of them to be a solution to the system. So I'm going to do 3 times 0 minus a -2. And I want to see if that equals 2. So 3 times 0 is 0, and then a negative and a negative would turn into a positive 2. So 0 plus 2 does equal 2. So as long as it works in both equations, then yes, 0, -2 is a solution to the system. On these types of problems, your work is your answer, showing that you plugged them in and that it is or is not a solution. Okay, now let's look at solving the system using substitution. So in substitution method, we want to get one of the equations, a variable by itself, to be able to plug into or substitute into the other equation. So I'm going to take the second equation and get y by itself. When I do, that would just be y equals x. If I move the negative x to the other side, it becomes positive x. So now what I'm going to do is I'm going to take what y equals, which is x, and I'm going to plug it into the y in the other equation. So now the other equation becomes 2x plus x equals 6. So now I'm going to simplify and solve for x. So this would be 3x equals 6, and therefore x equals 2. Once I know what x equals, then I can plug it back into any of the original equations to find out what y equals. I'm going to plug it into the simplified second equation. So I'm going to plug it in right here for x. And because y equals x, then it is also going to be 2. So the solution to the system is 2, 2. So if I graphed both of these equations, they would intersect at the ordered pair 2, 2. Okay, same thing for number 3. We're going to solve using substitution. So you want to solve one of the equations for one of the variables. Either one is fine. To me, it looks like it would be easier to solve for y. So I'm going to take the top equation and get y by itself by subtracting the 3x to the other side. So it becomes y equals negative 3x plus 2. So I'm going to take this whole expression and substitute it in for y in the other expression. So now I have x cubed minus 2 minus 3x plus 2 equals 0. So I'm going to simplify, and you'll notice that the negative 2 and positive 2 are going to cancel. So x cubed minus 3x equals 0. Okay, so I need to solve for x. Well, these two terms both have an x in common, so I'm going to factor it out. When I factor out the x, I'll be left with x squared minus 3 in the parentheses. Now that it's factored, I can set the two factors equal to 0 and solve. So the first one is just x equals 0. The second one, x squared minus 3 equals 0. I'm going to add 3 to both sides, and then I'm going to take the square root. Remember, when you take the square root, it should be the positive and negative square root of 3. Well, now I have 3 values of x that I need to plug back in and find 3 values of y. So let's start with 0. So I'm going to plug it back into the equation that I circled. So negative 3 times 0 plus 2. So that's going to equal 2. So the ordered pair for this solution would be 0, 2. Now I'm going to take the positive square root of 3 and plug it in. So negative 3 times square root 3 plus 2. Well, all I can do is drop the parentheses here. I can't do anything to simplify. So it's just negative 3 square root 3 plus 2. As an ordered pair, it would be positive square root of 3, comma, negative square root of 3, or sorry, negative 3 square root 3 plus 2. Same thing for negative square root of 3. I plug that in. Now this time, a negative times a negative will result in a positive 3 square root 3 plus 2. So my ordered pair here is negative square root 3, comma, 3 square root 3 plus 2. So here are my 3 solutions to this system. If I graph these two functions, they would intersect at these 3 places. Okay, example 4. So I know we're looking at this and we're probably panicking because we see fractions here, but no need to worry. This is going to be simple. So if I take the second equation and get x by itself, I would have had to move the negative 5 over 6y to the other side, but then I would have to divide by a negative to get x to be positive. So when I do, that changes the sign of everything. Or you can think of it that I move the x to the right-hand side and move the 7 to the other side. Same difference. So I'm going to take this whole thing and plug it in for x in the top equation. So now this is going to be 6 times negative 5 over 6y plus 7 plus 5y equals negative 3. So I need to distribute the 6 into the parentheses. Well, when I multiply 6 times negative 5 over 6, the 6's are going to cancel. So this would be negative 5y. Then when I distribute the 6 to the 7, that would be 42. Everything else stays the same. So negative 5y plus 42 plus 5y equals negative 3. Well, if you notice, the 5 y's are going to cancel here. And I'm going to have 42 equals negative 3. Well, 42 can't equal a negative 3. Two numbers can't be the same. So in this situation, when you have something, a number equals a totally different number, that means that these two do not intersect. So there is no solution to this system of equations. Okay, number 5. X plus y equals 4, and I have x squared plus y squared minus 4x equals 0. So we're going to solve by graphing in this system of equations. So in order to solve by graphing, we can use our calculator, but I'm actually going to graph it on here as well. In order to use our calculator, we have to get y by itself. So for that first equation, all I have to do is move the x to the other side. So it becomes y equals negative x plus 4. The second equation is going to take a little bit more steps. So let's go ahead and graph this first equation. So you can use your calculator, plug it in, and go to the table of values. Or if you remember, when you're graphing a linear function, the trick is that the second number, the 4, is the y-intercept. It crosses at positive 4. And then the slope is negative 1. So it goes down 1 over 1. So I've plotted a few points. So I have negative 2, 6, negative 1, 5, 0, 4, 1, 3, and 2, 2. And I connect the dots, and here's the first function. Okay, the second function is going to take a couple of steps before we get y by itself. So first thing I would need to do is move the x squared and the negative 4x to the other side. So that would give me y squared equals negative x squared plus 4x. Well, then I need to take the square root of both sides to get y by itself. And remember, when you take the square root, it's the positive and negative value. So y equals the positive and negative square root of negative x squared plus 4x. Well, when you go to put this in your calculator, you don't have a plus or minus button in your calculator. So you're going to have to put this in as two separate functions. So you can put the positive square root in y2 and then the negative square root in y3. And you want to keep the blue equation, negative x plus 4, in y1. We want all of these in the same graph so we can see where they intersect. So you can go to your table and get some values for y2 and y3 and plot your points. So if I look at the table for y2, the positive square root, these are the values that I get. 0, 0, 1, 1.7, 2, 2, 3, 1.7, 4, 0. Then when I look at y3, which is the negative square root, these are the values that I get. 0, 0, 1, negative 1.7, 2, negative 2, 3, negative 1.7, and 4, 0. So if you look at this graph as a whole, this is actually a graph of a circle. Okay, so now we can see the two places that these two functions intersect. Not always are we going to have two. Sometimes there's one solution, 2, 3. There can be a bunch of solutions or no solutions at all. For this system of equations, the solutions happen to be 2, 2, and 4, 0. Okay, number 6, same thing. We got to get y by itself first before we can graph these. So for the first equation, I need to subtract x and divide everything by 2. So that's going to give me y equals negative x over 2 plus 4. So when I put this in y equals and go to the table, here are the values that I picked. I tried to pick some whole numbers. So negative 2, 5, 0, 4, 2, 3, 4, 2, and 6, 1. And you'll notice that this line crosses at positive 4 and has a slope of negative 1/2. It goes down 1 over 2. Okay, for the second function, if you have an 84 plus, you can probably type it in just as it is. If you have an older calculator, then you need to type it in as log x divided by log 2 using the change of base formula. So we're going to get some crazy decimals here. So I just try to find the closest ones I can to whole numbers or whatever decimals make the most sense for this problem. So I started with 1, 0. I went to 2, 1, 4, 2, and then 8, 3. And if you look at the graph of this one, it's getting closer and closer to 0 actually from the right-hand side. Okay, so these two functions intersect at one place, and that place happens to be 4, 2. So the solution to this system is 4, 2.